Welcome everyone. In this video, I will be solving questions regarding redox reactions. So we will start with the first question. In here we have two half equations shown here. So this is the first half equation and this is the second half equation. So the equation for the reaction between manganate ion and sulfate ion is shown here. Which statement is correct? So look guys, this equation, this one, is got from adding these two equations together. Okay, so if we add these two equations here, if we add this equation 1 with equation 2 together, we will get this equation. And to answer the question correctly, our problem is point 1. We need to make sure that u equal to x and z. Here u equal to x and z to make sure whether this one is correct or not. We have to add these equations together and find the correct answer. So now what I'm going to do is adding these two equations. These are half equations because they have electrons. And as you see here, guys, this equation is reduction, this one is oxidation. To add them, we have to balance the number of electrons in both equations. They are not balanced. So equation 1 should be multiplied by 2, and equation 2 will be multiplied by 3. In this scenario here, the electrons, they will be 6, and the electrons here will be 6 as well. So what will happen is we will have 2MnO4 minus, we will have 4 H2O, 6 electrons here, and we will have 2 MnO2 and 8 OH minus. And in this case here, we will get 6 OH minus, and we will have 3 SO3 minus 2. We will have 3 SO4 minus 2, and we got 3 water and 6 electrons. After balancing, guys, we can remove the electrons from both sides and adding these two equations now. So when we add them, we just have 2MnO4. So here we have 2. 6 OH minus. Look, guys, here we have OH minus. Here we have OH minus as well. They are on different sides of the equations, so they can be cancelled. Here we have 2 OH minus remained. Here no OH minus remained. Yeah. SO3 minus 2, here we got 3 of it. Water, guys, 1 will be remained here, 1 H2O. Here we have 4, here we have 3. So 1 H2O remained. In the product side, how many MnO2? We got 2 MnO2. And for SO4 minus 2, we got 3 of it. For OH minus, we got 2 of it. So the do u equal to x and z. U is 2, x2, z2, so this option is correct. Manganese is reduced to oxidation state +4. Mn here, guys, it is x, oxygen is -2 plus multiplied by 4 because we have 4 of it, equal to -1, the sign. So x minus 8 equal -1. In this scenario, x will be 7. And Mn here 7. And Mn in this compound is x minus 2 times 2 equals 0 because we have no sign of it. So x here will be 4. The oxidation number of x here is 4. So Mn goes from +7 to +4. So from +7 here to +4. So yes, manganese is reduced. Sulfur is oxidized from oxidation state +4 to +6. Guys, sulfur here is x, oxygen is -2 times 3 equal to what? Equal to the sign or the charge. So this one will be equal to -2. In this scenario, x minus 6 equal -2, so x will be 4. So here x was a +4. If you use the same method that I did, you will find s here equal to +6. So this one is correct. So the option A here is the correct option. Right. Let's move to the next question. Right. Hydrogen peroxide H2O2 decomposes to form water and oxygen. The reaction is catalyzed by bromine ions. Br minus is the catalyst. So which one is correct? Type of catalyst, heterogeneous or homogeneous? So as we know that heterogeneous catalyst, when the catalyst and the reactant are both in different phase, but here the catalyst, which is a bromide ions, and H2O2 are both in the same phase. Both of them are aqueous, so they are homogeneous. So either C or D are the correct answers. Right, let's move to the next option. Bromide ion oxidize, bromide ions are reduced. Look guys, and here in step 1, he talks about step 1. In step 1, as you see, we have Br minus, it was -1, then it becomes Br2, which has oxidation of 0. So bromide ions are oxidized. So the correct answer is C. Yeah, it is C. Moving to the next one. In the treatment of domestic water supplies, chlorine is added to water to kill bacteria. Guys, chlorine is Cl2. Some ClO minus ions are formed. What's the change of oxidation number of chlorine when forming ClO minus from aqueous chlorine? So Cl2 aqueous, it becomes ClO minus. Guys, Cl2 has oxidation number of 0, but here it is X. Oxygen, guys, it is always has oxidation number of -2, except in F2O. Here oxygen is a +2. So oxygen always is -2, and this will be equal to -1. So X equal to 2, we take to the side, 2 minus 1, X will be 1. Okay, so X was 0, then it becomes a +1. The correct answer is C. Moving to the next question. NCl3 reacts with water. We have this reaction here. The oxidation state of nitrogen does not change in this reaction. Okay. Which statement is correct? So look guys, the oxidation number. If we talk about NCl3 now, we don't know which one will have the negative sign. Okay, it's difficult to know which one will have the negative sign. Is nitrogen -3 and the chlorine is a +1 here, or nitrogen +3 and the chlorine -1? This is difficult to know, but let me show you something. Hydrogen in here, hydrogens are +1, and oxygen here is -2. Right. And if we talk about this compound, hydrogen is a +1 And the chlorine, guys, will be +1 as well, and oxygen -2. Okay, so yeah, in this scenario, all hydrogens here are a +1. We have 6 hydrogens, all of them are +1. And hydrogens here are a +1 as well. Here +1, a +1, a +1, +1, a +1, a +1 here. They remain the same, no change. 3 oxygens here are -2. 3 oxygens here, all of them are -2. So guys, this reaction is described as not redox reaction. It's considered as not redox reaction because nothing happened for this reactant at all. Nothing happened for this reactant at all. Okay, so this is not redox reaction. One of the reactants remains the same. No oxidation or reduction occur to it. And we understand this from the products. Slightly tricky question, but yeah. Right, moving to the next question. In which row do the oxidation number of vanadium increases? We are going from the smallest oxidation number to the largest oxidation number. Right, look guys, as we said, oxygen is always -2. So if we count in this compound, we will see that V is X, X -2 times 4, because we have 4 of it, equal to what? Equal to the charge minus the 3. So X -8 equal -3. X here, guys, equal to 5. Here 5 is the smallest. And if you count the V here in the same way I did, you will find that here we have 5 as well. And here we will have, let's see here what we'll have. X -2 times 2 equal to +1. Okay, so X here will be 5 as well. So here, this is not the correct answer. All them, they have the same oxidation number. طيب. VO +2, we say it's 5. It has oxidation number of, no, sorry, not 5. Let's calculate it. V is X -2 because we have 1 oxygen equal to +2. So here X will be 4. The oxidation number of 4. Here we have V2O3. So look guys, V2O3 means we have 2X -2 times 3 will be equal to 0. And 2X -6 equals 0. X will be 3. So we are not going from the smallest to the largest. B is wrong as well. Here we counted the V. V was +3. Here, guys, V is +4. Okay, if you just count, it will be +4. And for this one, so as we said, X -2 times 3 equal -1. X will be, here we have -6. So X -6 equal to -1, X equal to 5. So our correct answer is C. We are moving from the smallest to the largest oxidation number. Right. Let's move to the next question. Yeah. So ammonium ions, NH4 plus, are converted into nitrite ions by bacteria to NO3 minus. What's the change in oxidation number of nitrogen? So we have NH4 plus and we got NO3 minus. Guys, and here is, yeah, it is X. Hydrogen is always plus 1. We have 4 of it equal to the sign, plus 1. So X equal to 1 minus 4, X equal to minus 3. So this is the oxidation number of nitrogen is minus 3. Just let us make sure. Yeah, minus 3. And here, guys, nitrogen is X minus, oxygen is always minus 2. We have 3 of it equal to minus 1. X minus 6 equal minus 1. So X will be 5. The change in oxidation number is from minus 3 to 5. Okay, from minus 3 to 5. So guys, here we have a plus 8 oxidation number. Okay, the change in oxidation number is plus 8. Moving to the next question. So we don't need to have a look on this. What is the correctly balanced ionic equation for this reaction? Look, guys, in this type of questions, we have to make sure about the balancing the number of atoms and balancing the total charge on each side. Okay, so talking about the total charge, let me show you something here. Here we have charge of minus 2, and here we have two hydrogen ions. So plus 1, plus 1. That means the charges are cancelled with each other and the total charge in this side is 0 now. But for this side, we have 2Cr plus 3, plus 3, plus 3. So the total charge in this side is a plus 6. The equation is not correct. So the charges must be equal. طيب, let's move to the next one. B. In B, the total charge, here we have minus 2 and 8H plus. So the total charge is a plus 6, right? And here we have 2Cr plus 3, so yeah, it is also plus 6. Now we have to count the atoms and ions. Are they equal to each other? Here we have 2Cr, here 2Cr. Total oxygen in this side, 7. And here we have 6 oxygens. So 7 plus 6, 13 oxygens. And here we have 7 oxygens plus 6, 13 as well. 8H plus and 6, 14 hydrogens. Here we have 14 hydrogens as well. So the correct answer is B. طيب. Moving to the next question. VO2Cr reacts with NaI under acidic conditions. The oxidation state of Cl is -1 in here and in here. In both scenarios is -1. Which row about this reaction is correct? Vanadium is oxidized. Vanadium and iodine. Which one is oxidized and which one is reduced? طيب. In all scenarios, Cl is -1. And VOCl2 and VO2Cl and VOCl2. Vanadium is -1. So guys, if you noticed here, Na is +1, I is -1. This is ionic compound and metals are always positive. And I goes from minus to I2. So we know that I is oxidized. It loses electrons. So iodine is oxidized. So we can ignore D and B. D and B are ignored. Right, let's talk about vanadium. Vanadium, guys, here is X. Look, we don't care about this number at all. Oxygen always -2, and they told us that Cl is -1, equal to 0. We have no charge here. So we have VO2. So we multiply this one by 2. So X -5 equals 0. X will be 5, right? Yes, X will be 5. And in VOCl2, if you notice that vanadium, oxygen -2, vanadium is X, oxygen -2, 2 Cl's, it is -1, -1 equals 0. And X in this scenario will be +4. So X goes from 5 to 4. This is reduction. Okay, so this is the correct answer, C. We move to the next question. When hydrogen iodide is reacted with concentrated sulfuric acid, several reactions occur, including, so we have 8 hydrogen iodide plus H2SO4. Okay. Which role gives the change in oxidation number of iodine and sulfur in this reaction? Right, iodine, guys, it is hydrogen is always a +1, I is -1 here, and then it becomes I2, which has 0 oxidation number, right? So it was iodine was -1, then it becomes 0. So the change in oxidation number of iodine is a +1. So either C or D will be the correct answer. We can ignore A and B. Talk about the oxidation of sulfur H2SO4. Hydrogen is always a +1. We have 2 of it, so times 2. Sulfur is X. Oxygen is -2 times 4 equals 0. X here will be 6. And for this one, guys, S, S here will be -2. Because you know, hydrogen is a +1, and we have another hydrogen +1 plus X equals 0. X will be -2. That's it. So we go from 6 to -2. +6 to -2, so we have -8. Sorry. -8 oxidation number. So the correct answer is D. طيب. The equation for redox reaction is shown. We have this reaction, this redox. Which species is being oxidized in this reaction? Which one of these being oxidized? So here we have SnCl2 becomes SnCl4. This is aqueous. That means we have Sn+2 Cl minus Cl minus. And this is aqueous as well. It will be Cn+4 Cl minus 4 Cl minus. So look, guys, Sn+2 becomes Sn+4. I hope this is quite clear. Okay, it was a +2, then it becomes a +4. So Sn+2 is the one that has been oxidized. Yeah. The correct answer is A. Right, moving to the next question. We solved such a question before. We want to make sure that the charges are balanced and the number of atoms are balanced as well. So let's have a look. For this one, the total charge here is plus 12. I hope you can calculate it correctly. 14 positive minus 2. But in this side, the total charge is a plus 8. Here we have a plus 6. 2 times 3 plus 6 plus 2 is plus 8. Option A is wrong. Moving to option B. In option B, minus 2, here we have a plus 12 as well. And this side, plus 6, plus 6. So yeah, the total charge is a plus 12. Counting how many oxygens we have. Here we have 7 oxygens. And here we have 7 oxygens as well. Okay. What about type? The problem is here we have 1Zn, here we have a 3Zn. So I didn't pay attention for this, so option B is wrong. And option C, guys, we see the same conditions. Here we have plus 12, here we have plus 12 as well. 3Zn, 3Zn, 7 oxygens, and here we have 7 oxygens, 14H plus, here we have 14H. So the correct answer is C. Right. Moving to the last question. Yeah. In catalytic converter, the exhaust system of a car, carbon monoxide is oxidized to carbon dioxide. Carbon monoxide, CO, becomes CO2. Nitrogen monoxide reduced to nitrogen. NO becomes not N, it is N2. Okay. What are change in oxidation number of carbon and nitrogen in these two processes? So look, guys, carbon here is X minus 2 equals 0. So X equal plus 2. But here X is a plus 4. The carbon here a plus 4. So the change in oxidation number, we goes from plus 2 to plus 4. So it is a plus 2. So this is the only correct option. D must be correct. To make sure, nitrogen here is X, oxygen minus 2 equals 0. So X will be 2. And then it becomes nitrogen 0. From plus 2 to 0, so it is minus 2. As we said, D is the correct option. Hope, guys, all of this easy now for you. Yeah, and thank you for watching the video.